AWS Incident Simulator, Episode 2. ALB 502 Bad Gateway. ECS Fargate containers OOM-killed. ALB has 0 healthy targets. Let's get into it. Alright, we have a P1 incident. Customers are reporting 502 bad gateway on our API. Let me first explain what a 502 actually means in the context of an application load balancer. When you see a 502 from an ALB, it specifically tells you that the load balancer received the request successfully. So DNS, CloudFront, and the ALB listener are all working. But when the ALB tried to forward that request to a backend target, either the target was not available, it closed the connection before responding, or the response was malformed. This narrows our investigation immediately to the targets behind the ALB. Let's confirm by hitting the endpoint directly. Notice the response time, 23 milliseconds. That's extremely fast for a 502. If the targets were timing out, we'd see 5 to 30 seconds. A near-instant 502 means the ALB didn't even try to connect to a backend. It immediately knew there's nothing healthy to route to. Let's validate this by checking the target group health directly. This will show us the state of each registered target. So we have 0 healthy targets. That's our immediate cause of the 502. But now the real question, why are they unhealthy? There are several possible reasons. The containers might have crashed. The application inside might be returning 503. There could be a networking issue between the ALB and the targets. Let's start at the ECS level. Is the service even running tasks? I'll check the ECS service status, which shows us the desired versus running count and recent events. This is critical information. ECS shows desired 3, but running 0, pending 0. Reading the events in order, the service launched 3 tasks, registered them in the target group, but then all 3 stopped. And now it says steady state, which might sound healthy, but it actually means the scheduler has exhausted its retry logic and stopped trying. On Fargate, when tasks repeatedly fail to start and stay running, ECS applies an exponential backoff and eventually parks the service. Now we need to know why the task stopped. Let's get the task stop reason and exit code. Exit code 137 across all 3 tasks. Let me explain what this means. On Linux, exit code 137 equals 128 plus signal 9, which is sigkill. On ECS Fargate, the container runs inside a group with a hard memory ceiling. When the container's resident memory exceeds that ceiling, the Linux kernel's out-of-memory killer sends sigkill to the process. There's no graceful shutdown, no warning, just instant termination. And notice the timing. Task started and died within 2 minutes. That tells us the memory leak is fast. Let's check what memory limit is configured in the task definition. So the hard limit is 512 megabytes, and we're running image version 2.4.1. The next question is, was this working before? If it was, something changed. Either the traffic pattern increased, or a new code version was deployed that uses more memory. Let's check the ECS deployment history to see when revision 4.7 was deployed and what was running before it. There's our smoking gun. Revision 47 was deployed at 10:42, and the tasks started dying at 10:44. The previous revision 46 ran perfectly stable for 18 hours. Let's diff the 2 task definitions to understand exactly what changed between them. Was it only the image version? Did someone change memory settings? Or were there environment variable changes? Root cause is clear. Version 2.4.1 introduced an in-memory response cache without a corresponding memory limit increase. The fix is a rollback to revision 46, which ran version 2.3.9 stably. I'm using force new deployment to ensure ECS replaces all tasks immediately. I'm also setting minimum healthy percent to 0 since we currently have 0 healthy tasks anyway. This tells ECS it's okay to proceed without existing healthy capacity. While the rollback launches, let's prepare for the future. I'm registering a new task definition revision with doubled memory, 1024 megabytes instead of 512. This way, when the dev team fixes the cache memory leak and redeploys 2.4.2, we'll have enough headroom. Better to have it ready than scramble again. The rollback tasks should be up now. On Fargate, provisioning takes 30 to 45 seconds, then the health check needs 2 consecutive successes at 30-second intervals, about 90 seconds total. Let's check ECS task status, then the ALB target group. Three tasks running. Now let's confirm the ALB has picked them up as healthy. Even if tasks are running, the ALB won't route traffic until health checks pass. All targets healthy. Final validation. Hitting the production endpoint the same way customers do, and checking CloudWatch to confirm the 502 error count has dropped to 0. This gives us full confidence the incident is resolved. Incident resolved. ALB 502 bad gateway. Fixed in production. Subscribe for weekly AWS troubleshooting. See you next time.